Okay, let's look at examples with inverses here. The very top first example here is, here we have the sine, not an inverse, regular trig function of 5 pi over 12 is equal to 0.96593. If we wanted to write a relationship amongst these values using an inverse sign, it would look like the following. Now remember, inverses map back, so inverse sign inputs a ratio, outputs an angle, where regular sign inputs an angle, outputs a ratio, okay? And I'll make this theta so it's the same. Okay, so then if I'm going to write a relationship here with inverse sign, I would say the inverse, and the ratio is 0.96593, is equal to the angle 5/12 pi. Okay? All right, more with the inverses. Evaluate each of the following using a unit circle. Confirm your answers by checking with a calculator. I'm probably not going to do that on the video here, but we should discuss our calculator a little bit. All right, inverse sine of 1/2. So now, what is 1/2? Is this a ratio or an angle? This is a ratio, and they're asking for what angle produces it. So I have my unit circle right here. When it comes to sine, we have a 1/2 here and a 1/2 here for sine values. But remember, we can only map back to one of them. And for sine, we only map back to quadrants 4 or 1. So this is going to map back to the angle pi over 6. Okay, let's go to this next one. Inverse sine of negative root 2 over 2, that is a ratio. So we are looking for that ratio. Negative root 2 over 2 is here and here. We're not allowed to map back to both. We're only for sine allowed to map back to quadrants 4 or quadrant 1. And you have to give your angle between negative pi over 2 and positive pi over 2. So our answer is not going to be 7/4 pi. It's going to be negative 1/4 pi. So we're going to go over here, negative 1/4 pi. Okay. Arc cosine, remember arc, we can say arc cosine instead of inverse if we want, of negative root 3 over 2. So again, this is a ratio, and we are looking for the angle, negative root 3 over 2. For cosine, negative root 3 over 2 happens here and here. But remember, we don't get to map back to two different places. We only get to map back to one. And for arc cosine, we go from 0 to pi. So the answer is only going to be 5/6 pi. Inverse tangent of 1. Inverse tangent of 1. Remember that tangent is the y over the x. So I'm looking for the places where y over x is 1. That happens here and here. But remember, arctangent only gets to map back to quadrants in angle, to angles in quadrants 4 or 1. So our answer will be angle pi over 4. Okay? Now, let's go to the next one. Solve the triangle in the figure for theta. Okay, well, so here's what we know. We know that, this is from this angle, this is adjacent, this is hypotenuse. So we're going to use the cosine of our angle theta is equal to 9/12. Okay? If I want the theta, I'm going to rewrite this with an inverse. Arc cosine of 9/12 is equal to what angle? That's what we're after. Now, it's not on my unit circle. It's a positive ratio, though. So I know that this angle is going to be some angle that's in quadrant 1, so less than 90 degrees, right? I'm going to grab my calculator and post it to show you. Give me 1 second. Okay, I have thrown up a calculator here. I'm going to show you the inverse cosine button on our calculators. So hopefully you're familiar with the TI-84. That's the calculator I'm going to be using, although any scientific calculator has inverse functions on them likely. Okay, if you look here, you will see an inverse cosine, inverse sine, inverse tangent. Those are the 3 inverse trig functions we've looked at so far. We are working here to solve for theta, so it's not on our unit circle. It'll be a calculator question. If it's something you should be able to recognize from your unit circle, then it would be a no calculator question. Okay, so I'm going to, if it's in blue, hit second. Ooh, I need to be careful. First things first, do I want my answer in radians or degrees? So under the mode option on your calculator right here, I got a little delay. It looks like I'm in the radian mode, okay? I can set, second, quit out of that. I'm okay with being in radians. So now I'm gonna go second arc cosine, and I have the ratio 9/12. Bottom of my calculator, hit enter. And 0.7227 is my angle. So theta is 0.7227. Okay. A little delay here in my screen sharing when I pull up the calculator, and that is the angle solved. Okay, so those are the buttons that you'll use when working with inverses. All right, and we will soonly discuss how we find the inverse of a cosecant or a secant or a cotangent. Those are not on your calculator. Okay, so a little bit trickier to find. Okay, things that we know so far, they negate each other, right? The inverse sine and the sine can negate each other as long as your ratio is between -1 and 1, right? And the more interesting way to discuss it is the bottom 3 things here, and that is when it's the angle, they negate each other when the angle is in one of the approved quadrants. So for sine, quadrant 4 or quadrant 1, so -pi/2 to +pi/2. For cosine, the top half, so 0 to pi. For tangent, -pi/2 to +pi/2. Okay, so now we can go and we can evaluate more trig inverses. Okay, so we'll do these now. This example 4. Okay, so pi/3, I know is here. That is an allowed angle, so these do negate each other, and our answer is pi/3. This one, sine of 2pi/3, well, that's right here. That sine value is √3/2. Now, I want to do the inverse of that ratio, right? So this input angle outputs a ratio. Now I have this ratio, √3/2, but my arc sine won't allow me to go to quadrant 2 or quadrant 3. So inverse sine comes along and it says, I see that ratio. I only know how to output into quadrant 1 and 4. So my output is actually going to be pi over 3, not 2 pi over 3. I think that's one of the probably the biggest errors that I see made is students think that they can just cancel. Okay, so is this one allowed when working with inverse sine? No. Is this one allowed? Yes. Okay. All right. How about this one? When working with cosine and inverse cosine is 2 pi over 3 allowed? Yes, it is allowed. So then these cancel and our answer is 2 pi over 3. Okay. Now let's go to the next one. Is negative pi over 3 allowed? And the answer is no. So you can't just go cancel. We have to think about, okay, so when I'm at negative pi over 3, I will get a positive cosine value. The inverse comes along and it sees a positive ratio. And it thinks I need to return an angle in quadrant 1. Okay. Now let's go to the next example here where we mix the two together. We have an inverse sine and we have a cosine. So cosine can take in any angle, right? It's when we do the inverse where there's a hiccup. So cosine goes 13/6. That is all the way around and 1/6 right here, right? Cosine goes, oh, okay, so I'm going to redraw it. It's kind of sloppy. 13/6 is right here. And that's all the way around, and it's a pi over 6. And the ratio here is root 3 over 2, comma 1/2, right? Well, the cosine inputs an angle, outputs a ratio. So this will equal inverse sine, and then whatever that inside stuff output, which was root 3 over 2. So sine with this ratio, it sees positive root 3 over 2 for sine, and it says sine produces that right here at this unit circle coordinate. So inverse sine says, oh, I see that ratio here. The answer is pi over 3. Okay, so it's kind of like a series of events. Let's try it again for this one. Here, inverse cosine is going to take in a ratio and output an angle. And then I need to find the sine of that angle, which will output a ratio. Okay, let's draw a picture. So since we know that 4/5 is a ratio, and it's a positive ratio, for cosine, it's going to be right here. 4/5 is not on the unit circle, so instead we label adjacent over hypotenuse. Pythagorean theorem says the opposite leg here is 3. Okay? Just in case you forgot what it was. leg squared plus leg squared equals hypotenuse squared. Okay. Now, inverse cosine ideally would give us that angle. I don't need to grab my calculator and find it because I actually just want to know what the sine of this angle is. The sine of this angle is the opposite leg over the hypotenuse. So the answer here is actually 3/5. So this one is a prime example where you don't always need to know the angle to complete the problem, okay? Let's look at the next one and see if we need to know the angle. So they're giving us an inverse tangent, which means this is a ratio, right? And then when I calculate all of this, it would be an angle. And I have to do the sine of that angle. So my answer will be a ratio. Okay. Now, this ratio is the ratio of the opposite leg over the adjacent leg, and it's positive. Well, inverse tangent only works in quadrant 4 and 1, so we must be here in quadrant 1 when my thing decides it wants to work for me. Quadrant 1, opposite over adjacent. This is the angle, okay? I don't need to know the angle. I don't need to grab my calculator and try to find it. I do need to do Pythagorean theorem, though. 4 squared plus 7 squared equals the hypotenuse squared. 16 and 49 is 65. So the hypotenuse is the square root of 65. Hypotenuse is always positive. Okay, so we didn't have to know it, but we did have to draw it, right, to get a picture of what's going on. So that returns that angle, theta. Now I need to find the sine of theta. Sine of theta is opposite over hypotenuse. And if I rationalize it, there's my answer. We did not need to know theta here either. All right, let's see if we have to know it in this case. Find the simplified version for cosine of arcsine of x over 3. Okay, well, x over 3 is a ratio, right? We're doing the inverse sine of a ratio. And the inverse sine of that will produce an angle. And when we find that, if we need to find the angle, we will answer what's the cosine of it, all right? Which would be the adjacent leg over the hypotenuse. I think we should start to draw it, okay? The reason that they're giving us this restriction is because inverse cosines take in ratios between -1 and 1. And so if that's the case, then we'll have to alter what's available or a possibility for the axis, okay? So that last bit is just to adjust what's allowed for the inputs. Okay, so I'm going to first draw this. So since they're giving me the ratio x over 3, and they're saying that that is for sine, that means that it is the opposite over hypotenuse. I could be up here in quadrant 1, or I could be down in quadrant 4, okay? Either one would be fine to draw, okay? I don't know if x is positive or negative. Either way, when I calculate the adjacent leg, right, here's the theta. When I calculate the adjacent leg, it's going to be a positive x value, so it's okay with whichever quadrant you draw it in, as long as it's 1 or 4, okay? I'm going to do Pythagorean theorem here. I don't know this side. I'll call it A. a squared plus x squared equals 9. A squared is 9 minus x squared. I know a is going to be positive. So this adjacent leg is the square root of 9 minus x squared. Okay? I didn't need to know the angle. I just need to know how to simplify, and it's going to be an algebraic expression, which is the adjacent leg, which is ugly, but it is what it is, 9 minus x squared, over the hypotenuse, 3. We did not need to know theta to finish the problem. Okay? That actually concludes this section.